We've seen that deep learning can be used for a range of different problems, including how deep learning architectures are now figuring out the protein folding problem. In other words, finding patterns in proteins. I mean, proteins as in the building blocks of you and I. So if proteins are the building blocks of you and I and deep learning is finding out patterns in that, how might we create such deep learning architectures? And if you see deep learning architecture, deep learning model is kind of another word that you can substitute in here for architecture. So when you see deep learning architecture, you can think deep learning model. And when you think deep learning model, you can think deep learning architecture. So how might we build such a thing? Now, this is kind of a segue to TensorFlow. The TensorFlow is going to help us build deep learning architectures or deep learning models. And now, of course, naturally, you're probably asking, well, what is TensorFlow? Let's figure this out. TensorFlow is an end-to-end machine learning platform. You can write fast deep learning code in Python, which is the language we're going to be using, / other accessible language such as JavaScript. And when you write that fast deep learning code using TensorFlow, that code is able to run on a GPU, which is a graphics processing unit, / TPU, which is a tensor processing unit, hence TensorFlow. We're going to see the significance of that in a moment. With TensorFlow, you're also able to access many pre-built deep learning models. When we saw types of learning, transfer learning is where you'll use a pre-built deep learning model. In other words, leveraging the patterns that one deep learning model has learned on another problem to your own problem. We'll see how we can use TensorFlow Hub to do that, which is a TensorFlow resource. Now, it's a whole stack. This is a follow-on from this point here. TensorFlow allows you to pre-process data. In other words, turn that data into numbers, model that data. In other words, build a neural network to find patterns in that data, and then deploy your model into your application. So depending on what you're building, you might want to take the deep learning model, such as in the case of our security recognition system. If we wanted to identify different types of cars, we might want to take our computer vision model and deploy it into our security camera and use that to detect cars that have maybe crashed into other cars. In my case, again, you can probably hear the sadness in my voice. It makes me emotional when I talk about my poor little car. And it was originally designed and used in-house by Google, one of the largest internet companies in the world right now that basically machine learning runs everything that they do, machine learning and deep learning. And it's now open source, which means we can leverage the tools that Google use to work on our own problems. So that's a bit of an idea of what TensorFlow is, but why TensorFlow? Well, it allows us easy model building. Now, again, this is from the TensorFlow website. We're going to get very familiar with this website. Robust ML production anywhere. So train your models, deploy them in the cloud, on-prem, which means on your server if you have one locally, in the browser or on device, no matter what language you use. Powerful experimentation for research. So if you found a new idea, such as DeepMind building a new deep learning architecture to discover patterns in protein folding, you might want to rebuild their research using a TensorFlow-powered deep learning model. And so we're going to be doing lots of this, easy model building. And we're also going to do a little bit of this throughout this course, but that's for later on. In the meantime, let's check out the tensorflow.org website. So here we go, an end-to-end open source machine learning platform. There's a lot going on here. So you've got some examples here. You can see, you can install it, you can learn it. There's the API. Probably the exercise for this lesson is to go to tensorflow.org and have a play around. Just get yourself familiar with the website. If you've never looked at this website before, there's probably almost too much here, so it can be a little overwhelming, but that's all right. Just follow your curiosity and see what's there. Let's go back here. Now, why else might we want to use TensorFlow? Now, this is 𝗧𝗯𝗹𝗲 𝗁𝗲, and this is a tweet that he put out recently. With tools like Colab, we'll get familiar with Colab, Keras. Keras is a part of TensorFlow, and TensorFlow. Virtually anyone can solve in a day with no initial investment, so that means basically for free, problems that would have required an engineering team working for a quarter is 3 months, and $20,000 in 2014, which is so true. So the resources we're going to use throughout this course, I mean, just 5 years ago, or just a little bit over 5 years ago, would have cost a fairly large amount to even get up and set up. And not only like the things that we're going to be doing ourselves, would have required a whole team working for a couple of months that we're going to be getting up and running within, in some cases, a few lines of code. So this is why it's really, really exciting to be able to use TensorFlow and these other resources here to work on deep learning problems. So now, we mentioned before, TensorFlow allows you to run your numerical code on a GPU/TPU. Now, what exactly is a GPU/TPU? If we come here, this is what, if you Google the photo of a GPU, you'll get up this, graphics processing unit. These are actually NVIDIA cards. This is an RTX 3080, and I believe this is a P100. So you don't need to worry too much about these. You can install these in your own computer, like these type. These are usually built for servers. Say you have like a warehouse of different computers. This is often what you'll get when you connect to a cloud-hosted GPU, but we're getting a little bit too ahead of ourselves. The major thing you need to know about these graphics processing units is that they're very fast at crunching numbers. So when I say we want to find patterns in numbers, these type of computing chips are very fast at finding or doing numerical calculations. In other words, finding patterns in numbers, the numbers that we've converted our data into. And in the case of TensorFlow, it also allows you to use TPUs, which are tensor processing units. Now, this looks like a pretty advanced piece of hardware. If we go here, what is a TPU? Again, for these questions where you have what is something, don't be afraid to look it up. Tensor processing unit. Whoa. Tensor processing unit is an AI accelerator application-specific integrated circuit developed by Google specifically for neural network machine learning, particularly using Google's own TensorFlow software. Okay. So this is what we're going to get familiar with. And so if you think of a TPU, if graphics processing units are fast at crunching numbers, well, a TPU is probably even faster. But we're going to see throughout this course how we can get access to these chips. If you don't have, I mean, unless you're Google, you probably don't have this in your computer right now or in your bedroom or something like that. You maybe not even have one of these, but that's okay. We're going to look at resources throughout the course that we can use to gain access to these fast computing chips for free. We've seen TensorFlow, discussed what it is and why we should use it, but we haven't actually discussed half of its name. I mean, what exactly is a tensor? Great question. Now, remember our slide for neural networks? I'm going to give you a little hint. Well, we kind of revealed this earlier, so spoiler alert. Remember how we started with our inputs, which is maybe some images, maybe some natural language text, maybe some sound waves, and then we create a numerical encoding. We pass that numerical encoding to our neural network, which learns patterns in that numerical encoding. And then our neural network outputs some kind of representation outputs. And then we convert those into something that we can understand. Now, the secret here is that these are tensors. Whoa. And so the most basic definition I can think of for a tensor is some way or some numerical way to represent information. Now, what that information is, I mean, that's totally up to you. But just think of it as if we wanted to encode these images into some kind of numerical form, we're going to be turning them into a tensor. And we're going to see this in practice as we write TensorFlow code. We're going to pass that tensor to our neural network. Our neural network is then going to figure out different patterns in these numbers, and then it's going to output another tensor, which is the patterns that it's learned in our original numerical encoding. And then we take this tensor, the representation outputs from our neural network, and convert them into something that we can understand. So if we take away some of the excess parts, this is the founding principle of neural networks and tensors in general. I mean, this is where the name TensorFlow comes from. If we imagine our inputs, our food image classification problem, we turn it into a numerical encoding, in other words, a tensor. We pass it to our neural network. Our neural network finds the patterns and then outputs those patterns that it's found, and again, this is another tensor, into something that we can understand. So if you imagine, this is the flow. This is where the flow in TensorFlow comes from. It starts here by creating a numerical encoding, then it flows through our neural network, then our neural network flows it on again, the output here, and then we, again, another little flow here into something that we can understand. So that's what you have to understand for the concept of tensors. If you want a little bit of an extension, I'll show you one of my favorite videos on what is a tensor. This can actually be your homework. Is this video here. So this is available on YouTube. What is a tensor? So I want you to watch this video, figure out Dan Fletcher's, I'm not quite sure how to pronounce that name, but Dan, also a great name. Watch Dan's explanation of what a tensor is, and then come back to the other Dan, me, and then see if you can line these up. Remember, a tensor is a way to represent some sort of data in numerical form. So if we come back, we've covered what TensorFlow is, we've covered what deep learning is, we covered what neural networks can be used for.